Hello there. I'm glad you've arrived. Maybe the day has been heavy on your shoulders, or maybe you simply like to drift off with a quiet sky in mind. Let yourself settle. Let the breath smooth out, like a tide returning to the shore. Tonight, we're going to wander softly through the most beautiful objects in the universe. We'll visit star nurseries where new suns are swaddled in dust, pause by sculpted pillars of gas and light, trace the strange geometry of galaxies that bend space into rings and crosses, and linger with elder stars whose final breaths paint the dark with color. Even the great empty places have their grace, a silence shaped by time and gravity. None of this is random. Beauty out there is physics unfolding patiently, precisely over billions of years. If this gentle journey helps you rest, a quiet like and subscribe would mean a lot. It helps other sleepy travelers find their way too. For now, let the noise of the day drift to the edges. We'll keep company with starlight, move slowly, and let wonder do what it always does: lighten the mind, one calm orbit at a time. Far above the northern horizon, in the quiet shoulder of the constellation Pegasus, there is something almost invisible. No color, no swirling arms, no glowing gas to catch the eye. Just 5 faint points of light, 4 bright, 1 dim, arranged in a near-perfect cross. To most, it would look like a flaw in a photograph, a trick of dust or distance. Yet those dots hold one of the most astonishing conversations the universe has ever had with itself. The story doesn't begin with the dots, but with the space between them. About 400 million light-years away from Earth, there floats a galaxy, unremarkable in its own right, a soft haze of stars and dust suspended in the dark. But directly behind it, unimaginably farther back, lies a quasar, nearly 8 billion light-years away. A quasar is a kind of cosmic beacon, the furious heart of a distant galaxy, where a black hole is swallowing matter so greedily that it shines brighter than 1 trillion suns. The light from that quasar has been traveling toward us for more than half the life of the universe, an ancient signal crossing the void. And then, one day, or one epoch, it met something in its path. The light did not stop, it curved. The foreground galaxy, by merely existing, bent the space around it. The gravity of its mass pulled at the fabric of space-time, shaping invisible valleys through which light flowed like water. And the quasar's light, instead of moving straight, followed those curves, slipping around the edges, folding through the dips, reaching us along 4 separate routes. What arrived here on Earth were 4 bright points, arranged around the central galaxy, a perfect cross of light. Astronomers call it the Einstein cross. It is not a reflection or an illusion. It is not a camera's mistake or a trick of the eye. It is light, ancient, furious light, bent by gravity into a shape that looks almost deliberate. More than a century ago, Albert Einstein proposed that mass curves space and that light, always following the shortest path, must bend along with it. His theory of general relativity was tested during a solar eclipse in 1919, when scientists measured the faint bending of starlight around the sun's edge. It was a small deflection, just enough to prove the idea. But even Einstein doubted the cosmos would ever arrange itself in such a way that we could see the full lensing effect, a great magnifying halo of light, split and multiplied by the weight of a galaxy. Yet, the universe is patient. In 1979, at Kitt Peak National Observatory in Arizona, astronomers noticed something peculiar: a quasar that seemed to exist in 4 places at once. The symmetry was unsettling, almost too precise to be real. But by 1985, with sharper instruments and gentler persistence, the truth came into focus. Those 4 bright points were not separate quasars. They were 4 faces of the same one, light taking 4 distinct journeys through warped space, each path bent by the same foreground galaxy, all converging here, where our planet happened to be in perfect alignment. It was one of the most exquisite confirmations of Einstein's vision. Not a line of math or an equation on a page, but a living image, a photograph of gravity sculpting light. When we look at the Einstein cross, we are looking at time itself, stretched and braided. Each of those 4 glowing points carries the same light, but from slightly different moments. Because each path is a little longer or a little shorter, each beam reaches us at a slightly different time. It's as though you shouted into a canyon and the echoes returned from 4 valleys at once, each echo the same voice, but layered in delay. The Einstein cross lets us see light not as a single instant, but as 4 whispers from across billions of years, each arriving just a little late, each a separate heartbeat in the same cosmic song. And the story deepens still. The galaxy doing the bending is not smooth and clean like glass. It is full of structure, stars, gas, dark matter, dust, all tugging at light in their own small ways. As those stars drift across the light paths, they create tiny, unpredictable flickers. These soft variations are called microlensing. To the naked eye, they would go unnoticed, but to astronomers they are priceless clues. By studying those minute changes, scientists can map the invisible skeleton of the galaxy's mass, how its stars are spread, how its dark matter flows. Even the quasar itself, hidden so far behind, reveals details of its structure through these delicate tremors. In a single image, a handful of faint dots, the universe offers a cascade of understanding. A quasar from its early youth, a galaxy bending space-time into a lens, light split by gravity into 4 versions of itself, and the living proof that space is not empty but elastic, shaped by the weight of everything it contains. But the beauty of the Einstein cross doesn't lie only in its science. It lies in its symmetry, in the way the universe, by pure coincidence, arranged such order from chaos. 4 points of light, evenly placed, glowing like a cosmic symbol. It looks designed, sacred almost, like something that might have been etched into cathedral glass or carved into ancient stone. Yet there it is, drifting alone in the deep, perfect by chance and by physics. It reminds us that harmony can exist inside distortion, that what we call chaos may simply be another kind of balance we haven't yet learned to see. The Einstein cross is an accident in the strictest sense, an alignment that depends on the precise position of 3 distant objects: the quasar, the galaxy, and us. Shift the galaxy slightly, and the cross dissolves. Move the quasar, and the pattern fades into blur. The beauty lives in the timing, in the fragile geometry of coincidence. Over millions of years, the alignment will drift, the image will warp, the cross will vanish, and another alignment somewhere else will take its place. But for now, for this brief shimmer of cosmic time, it is there, shining across billions of light years to reach our small world. And maybe that's part of the wonder. The light we see left its source before the earth had mountains or oceans, before life had stirred in the sea. It traveled through expanding space, through ages of silence, through collisions and births and deaths of stars, and still it came here, gentle as a memory. 4 versions of the same ancient light, converging on our night sky, carrying within them the curve of space-time and the whisper of gravity. If you look long enough, if you could see beyond the faintness and into the meaning, you might sense the rhythm of it. The universe folds and bends, not in haste, but with infinite patience. And in those folds, where light takes the long way around, beauty finds its shape. The Einstein cross isn't just an object in the sky. It's a quiet statement from the cosmos itself, that symmetry can rise from randomness, that alignment can be born of chance, and that even gravity, the same force that pulls our bodies to the ground, can also lift our eyes towards something ineffably perfect. Somewhere, out there, that cross of light still hangs 4 tiny stars around a ghostly center, marking a conversation between matter and time. And here, under our small, familiar sky, we listen. Somewhere, out there, that cross of light still hangs 4 tiny stars around a ghostly center, marking a conversation between matter and time. And here, under our small, familiar sky, we listen. If you follow that listening long enough, your thoughts might begin to wonder what else might be shining quietly in the dark. The universe, for all its storms and chaos, has a strange habit of arranging grace in the midst of motion. And if you turn your gaze toward the southern edge of Virgo, on a night clear enough for starlight to whisper through, you might find one of those rare arrangements, a faint oval glow, almost lost in the background, that sharpens slowly through a telescope until its form becomes unmistakable, a bright white core wrapped in a band of shadow, like a coin dipped in dusk, or a pearl held between 2 fingers of smoke. Astronomers call it the Sombrero Galaxy. The name sounds playful, almost too simple for something so grand, but it fits perfectly. The galaxy truly resembles a wide-brimmed hat light, crowned by darkness, geometry outlined in dust. A central bulge rises luminous and round, encircled by a razor-thin band of shadow that marks the edge of its dusty ring. Beyond that, faint light spreads outward, a soft disk of stars stretching for tens of thousands of light years. In the quiet of space, it floats like an idea suspended between symmetry and shadow. Long before anyone could see it in such clarity, a French astronomer named Pierre Méchain spotted its faint shimmer in 1781. His friend, Charles Messier, added it to a growing list of celestial objects, calling it Messier 104. For more than 2 centuries, it remained one of the sky's many gentle mysteries, a dim blur, alluring but indistinct. Then, in 2003, the Hubble Space Telescope turned its unblinking eye toward it. The image that followed became one of the most downloaded photographs of the early internet. Delicate filaments of dust curled around a glowing center, every thread visible, every contour exact. For the first time, we saw not just a galaxy, but a portrait, the cosmos rendered in perfect contrast. The Sombrero lies some 31 million light-years from Earth. The light that touches your eyes when you look at it tonight began its journey when saber-toothed cats still roamed the continents. By the time it arrived, civilizations had risen and vanished, seas had shifted, and the planet had changed its face. That light is ancient history traveling through the present, and it reveals a galaxy of remarkable structure. Astronomers describe the Sombrero as an SA-type spiral galaxy, a vast, flattened disk with a large central bulge and tightly wound spiral arms. Yet we see it nearly edge-on, which hides the spiral pattern and leaves us only the silhouette of its ring. That dark band circling the middle is not emptiness, but substance, a thick lane of dust and gas, so cold and dense that visible light cannot pass through it. Radio telescopes, peering beyond what eyes can see, have found that these shadows are alive with motion, They hold molecular gas, the raw material of creation. Inside that obscuring dust, stars are forming slowly, quietly, their heat detectable only in infrared. Seen through telescopes like Spitzer or James Webb, those hidden nurseries glow faintly, like embers behind a veil. It is humbling to know that what looks like darkness is, in truth, light preparing to be born. At the heart of the sombrero lies something immense, a supermassive black hole with the mass of nearly 1 billion suns. It anchors the galaxy in its gravity, unseen yet absolute, pulling stars into smooth orbits, binding chaos into order. Around it, entire systems revolve, their paths stable for millions of years. There is no sound, no flare, only motion, serene and relentless. What we see as calm is the balance of unimaginable forces. Beyond the disk, the sombrero extends into a vast halo, a sphere of old stars and globular clusters dense, ancient gatherings of hundreds of thousands of suns. More than 2,000 of these clusters have been counted, nearly 10 times as many as our own Milky Way possesses. They drift in gentle arcs, fossils from a time when galaxies were young. Their presence hints that the sombrero may not fit neatly into any one category. Some astronomers believe it is a hybrid, part spiral, part elliptical, a bridge between two great families of galaxies, as if caught in the act of becoming. And that balance, the tension between two identities, is what makes it so mesmerizing. Its shape feels deliberate, sculpted by some invisible hand. The central bulge sits perfectly round. The disk is even, the dust band precise. It looks less like an accident of gravity and more like an act of design. But of course, this stillness is an illusion. Every pinprick of light is a sun in motion. Every ribbon of dust is drifting, bending, pulled by tides of dark matter. The calm we see is choreography, not silence. The galaxy is dancing, but at a tempo too slow for our eyes to catch. When you stare at it long enough, you begin to sense that it's not just beautiful, it's contemplative. The light feels patient, the structure feels wise. There's something in its balance that speaks of time doing its work with quiet precision. Still, perfection never holds for long. Even this masterpiece carries small imperfections, the kind that make it real. The dust ring, for instance, is not flat. It's subtly warped, as though the edges were lifting in opposite directions, twisting ever so slightly like a ribbon caught in a breeze. That gentle asymmetry reminds us that nothing in the universe is truly still. The edges of order always curl toward motion. Look closer, and you'll notice that the sombrero's glow, so pure at first glance, is built from countless individual lights. Some are ancient red stars, dim but enduring. Others are young and blue, newly born from the dust. Together they blend into a white brilliance that floods the core. Around it, darkness folds like hands in prayer. The dust doesn't just frame the light, it sculpts it. The black lanes block the stars behind them, creating contrast so sharp that the galaxy seems to shine from within itself. That's why it looks like a hat. That's why it gleams so cleanly against the void. Its beauty is born of opposition, light defined by shadow, clarity made possible by what hides. And there is still so much hidden. Even now, with instruments capable of seeing across wavelengths, the sombrero keeps its secrets. Astronomers still don't know why its halo holds so many clusters or what history shaped its hybrid nature. The black hole at its core is silent, withholding the details of its past. Perhaps the dust conceals more than starlight. Perhaps it conceals time itself, folded and waiting. Yet maybe that's part of the gift. Not everything must be solved. Some truths can stay just beyond reach, their outlines enough to stir wonder. The sombrero reminds us that science and mystery are not opposites. They are partners in the same slow dance. What we can explain gives us knowledge. What we cannot gives us awe. So there it floats, 31 million years of light away, luminous and composed, wearing its ring of dust like an ornament of gravity. A galaxy shaped by time and tension, by collapse and creation, by the same laws that hold the atoms in your breath together. Through a small telescope, it may seem faint, but once you've seen it, the image lingers. The white glow, the dark band, the sense of impossible balance. And when you close your eyes, you can almost feel that symmetry hum beneath your thoughts, as if the mind itself were tracing the shape of a cosmic hat, turning slowly in the dark. The sombrero drifts on, a reminder that even amid explosions, collisions, and chaos, the universe sometimes pauses just long enough to make something quietly, perfectly still. But not all galaxies get to live that way. Some never stop moving. Some are pulled and stretched, broken and reshaped, caught in slow, endless dances they can't escape. Beyond that tranquil disk of light and dust, beyond the calm geometry of balance, there are places where gravity never sleeps, where beauty and violence are woven into one. Out in the deep between the great clusters, where the sky is darker than any night we know, 5 galaxies hang together in space. From afar they appear serene, a handful of silver smudges softly blending their edges. Their halos touch like fingertips. Their arms seem to reach in welcome. The illusion is so gentle, it almost feels kind. But step closer, even in imagination, and the scene changes. You begin to see what's really happening beneath that calm light. The galaxies are not meeting in peace. They are colliding. This is Stephan's Quintet, one of the most breathtaking gatherings in the universe, a still picture of a storm that has raged for hundreds of millions of years. It was first noticed in 1877 by Édouard Stephan, watching through the eyepiece of the Marseille Observatory's telescope. In that trembling image of faint, clustered smears, he saw something odd. 5 galaxies, all too close, too dim, clustered like whispers in the same patch of sky. He could not yet know what he was looking at. It would take a century of better instruments and careful minds to understand that what he had discovered was not a quiet cluster, but a meeting of giants. The 5 galaxies are not all truly together. One, called NGC 7320, only seems to belong. It floats much closer to us, around 40 million light-years away, like a lone actor standing too near the stage. It happens to lie perfectly in the line of sight, framed against the chaos far behind it. The others, NGC 7317, 7318, A 7318B, and 7319 are bound together by gravity, performing a slow, elaborate dance that has been unfolding for hundreds. Imagine the scale. Each of those galaxies holds hundreds of billions of stars. Each one is a city of suns and dust, spiraling through a shared darkness. Over time, their mutual gravity has drawn them closer, bending their shapes, distorting their arms, stripping gas and stars from their edges like fabric caught in wind. They brush past one another, their halos colliding invisibly, flinging ribbons of light outward into the void. These trails, called tidal tails, are the fingerprints of their encounters, long, glowing scars that twist and curl for hundreds of thousands of light years, tracing every moment of contact and departure. Through an ordinary telescope, they seem caught mid-motion, a snapshot of something halfway between destruction and creation. The spirals are smeared, their arms unfurl like silk underwater. The space between them glows faintly with heat from gas, shocked by collision. One galaxy, NGC 7318b, slices through the group at nearly 900 kilometers per second, fast enough to cross the entire United States in 5 seconds. The violence of that impact sends shockwaves through the intergalactic gas, creating waves of compressed matter heated to millions of degrees. That glow, invisible to our eyes, shines bright in X-rays. NASA's Chandra Observatory has mapped those waves in arcs of soft blue, while the James Webb Space Telescope has revealed what lies beneath: filaments of dust, hidden star nurseries, pockets of light still in the making. In the Webb images, the chaos softens into color: amber, rose, and deep gold, each hue marking a different temperature, a different age of starbirth. You can almost see the process itself: destruction, feeding, creation, gravity, recycling matter into new light. It's tempting to call this violence, but out there, there's no anger in it, no will. The galaxies are not enemies, they are participants in a natural ritual as old as the universe. This is how galaxies grow. They meet, they merge, they become. Every collision is an exchange, a mixing of stars and gas, a redistribution of mass. In the slow arithmetic of cosmic time, nothing is lost. Each member of Stephan's quintet contributes its own story to the whole. NGC 7319, the brightest, shelters a quasar, a supermassive black hole that feeds on surrounding gas, flaring in bursts of X-rays. NGC 7317, smaller and rounder, drifts on the group's edge, less scarred, holding its shape as the others twist. The twin galaxies, 7318A and 7318b, are the dancers at the center of the storm, spiraling around one another, their meeting fresh and hot. In their wake, clouds of gas and dust light up with the shock of impact, glowing faintly as they cool. Astronomers studying this group speak of tidal tails and starburst regions, but the words barely touch the feeling of what they're seeing. These tails stretch for more than 200,000 light years, streams of light and dust arcing across the black, looping back, curling like ink on water. In their folds are knots of brightness, new stars forming in the aftermath of collision. Through Webb's infrared view, these pockets shine like candles through smoke. Even as galaxies are torn apart, life, stellar life, begins again. That's the quiet miracle of Stephan's quintet. It is both wound and healing, destruction and rebirth. Its beauty is not the polished beauty of stillness, but the kind that trembles and glows with motion. Every photon we see from it carries the record of change. And in its tangled light, there's something else, a reflection of our own future. In roughly 4 to 5 billion years, our Milky Way will collide with the Andromeda Galaxy. The night sky, if there are eyes left to see it, will fill with streaks of starlight. Whole constellations will twist and disappear as gravity reshapes our cosmic home. There will be no sound, no fire, no apocalypse, just an immense, graceful merging. Stars will pass through one another unharmed, like ghosts, while their orbits warp and stretch. New stars will form from the debris. Eventually, the two will fuse into one vast, elliptical galaxy, its light smoother and rounder than before. Stephan's quintet offers a preview of that destiny. It is a mirror held far away and far ahead, showing what happens when galaxies meet, when time decides to mix what was once separate. The same forces at play there, the same patient gravity, the same silent choreography are at work here, shaping our own fate in slow motion. Astronomers believe that the galaxies of Stephan's quintet will ultimately merge into a single enormous structure. It may take another billion, maybe 2 billion years, but the outcome is certain. The arms will fade, the distinct shapes will blur, and what remains will be one vast, round glow, surrounded by a shell of wandering stars, the ghosts of its violent past. That shell will shimmer faintly in the dark, a reminder that every act of destruction in the universe leaves a trace of beauty behind. The light we see now is old. It began its journey before the Earth's continents had drifted into their current form. By the time it reached our telescopes, the galaxies themselves had already changed. We are not looking at what is happening. We are looking at what was, at ancient motion, already complete. The photograph of Stephan's quintet is a time capsule, a message from the past, carved in photons. The scene we call now is millions of years gone, yet the light still carries its story to us, quiet and precise. And beneath that story lies something deeper than the science. Beneath the collisions, beneath the burning gas and shattered arms, there is a kind of grace, the grace of inevitability. Gravity has no cruelty in it. It simply moves, shaping and reshaping the universe with unending patience. It is the reason things fall, and the reason galaxies hold together. It builds beauty out of chaos, order out of motion. If you were to drift there, in some imagined ship, you would see rivers of stars flowing like molten light. You would pass through tendrils of gas glowing faint blue, through vast silent corridors where new suns are being born. You might feel the pull of those distant giants, their motions almost imperceptible, like breathing stretched across eternity. The scene would not be terrifying, it would be serene, in the way that storms are serene when watched from above. Stephan's quintet is that view made visible to human eyes, the still frame of a storm too vast for us to witness in motion. The sombrero taught us that symmetry can be peaceful. Stephan's quintet teaches that chaos can be creative. Both are parts of the same truth the universe builds through tension, balancing the calm with the wild, the order with the storm. And as those galaxies twist and merge, somewhere beneath their glowing arcs, new stars are being born. Light that will travel for billions of years before finding another eye to witness it. Maybe, far in the future, someone will look at the remnants of Stephan's quintet and see only one vast, calm galaxy. They won't see the collisions or the shock waves or the long filaments of torn starlight. They'll see stillness, and they'll never know that once, in the darkness, 5 galaxies moved together like sparks caught in the same breath. So when you look at that image, 5 faint shapes suspended in the night sky, remember that it is not frozen at all. It is alive. It is happening, just slower than any heart could feel. It is a reminder that nothing in the universe truly stands still. The quiet we see is only the surface of endless motion, and even in that motion, there is music, the slow, deep rhythm of gravity playing across time. And perhaps, if you listen long enough, you might hear a faint echo of it within yourself, for the same laws that draw galaxies together also hold your body to the earth, your breath to your chest. The same balance that sculpts the stars keeps your heart steady in its orbit. We are not separate from that dance. We are one of its quieter steps. Something is hidden in that rhythm, the secret pulse of motion that shapes everything from the fall of an apple to the birth of a star. Somewhere between gravity and light, creation begins again. And so we drift from the clashing harmony of Stefan's quintet towards something softer, though no less profound. A place where destruction gives way to birth. There, in the constellation Serpens, about 7,000 light-years from where you rest tonight, a cloud of gas and dust stretches through the dark like smoke rising from an unseen fire. At first glance, it looks fragile, ghost-like. But inside that cloud, stars are being born. This is the Eagle Nebula, and within it stands one of the most iconic sights ever captured by human eyes. An image so breathtaking that it changed how we imagine the universe itself. They call it the Pillars of Creation. In 1995, NASA's Hubble Space Telescope turned its gaze toward this region and saw something that would soon circle the world: 3 towering columns of gas and dust carved into shape by light itself. They rise like mountains in a dream, immense and radiant, illuminated by newborn stars hidden within and around them. Hubble's photograph became more than just an image. It became a symbol, a window into the very process of creation. It appeared in classrooms, on posters, on mugs and t-shirts. People who had never thought much about astronomy looked up and saw art written in starlight. The pillars dwell inside the Eagle Nebula's heart, about 7,000 light-years away, so far that the light we see tonight began its journey long before the first cities were built on Earth. 1 light-year is the distance that light travels in a single year. About 5.88 trillion miles, racing at 186,282 miles per second. Multiply that by 7,000, and the numbers lose meaning. What matters is the feeling, the idea that what we're seeing is a memory of light that left before humanity existed. Each of the pillars is enormous. The tallest stretches roughly 4 light-years from base to tip, about the distance from our Sun to Alpha Centauri, the nearest star system. What looks soft and hazy in photographs is anything but gentle. These are colossal towers made of cold hydrogen gas and dust, thick enough to block starlight and dense enough to collapse under their own gravity. Within those folds, tiny knots of material grow heavier and hotter until one by one they ignite into stars. The light from those newborn suns sculpts their surroundings, pushing and pulling, tearing away the edges, while triggering new waves of formation deeper inside. Creation and destruction, side by side. The shapes are sometimes called elephant trunks, a name given more than a century ago by astronomer John Charles Duncan, who first photographed them in 1920 at the Mount Wilson Observatory. The term fit the columns curl and taper like the trunks of living giants, but in truth, they are not solid objects. They are filaments of vapor and dust, changing constantly as stellar winds carve them, like cliffs worn smooth by invisible tides. The name Pillars of Creation has an even older story. It comes from an 1857 sermon by the preacher Charles Spurgeon, who used the phrase to describe the power of divine creation. More than 100 years later, that same phrase would find new life in astronomy, describing something both spiritual and scientific. The universe building itself, particle by particle, through the laws of physics. The light that illuminates the pillars comes from hot, massive stars just beyond them. These young suns, only a few million years old, emit fierce ultraviolet radiation that strips electrons from atoms and heats the surrounding gas. The bright edges of the pillars, those glowing outlines that look almost painted, are where this radiation meets dense matter. It's a boundary, a frontier of creation, where starlight and shadow wrestle continuously. When Hubble captured its famous image, astronomers compared the scene to castles, to coral reefs, to fingers of smoke reaching upward towards something unseen. It looked eternal, untouchable. But like everything in the cosmos, it is in motion. The pillars are evaporating, being eaten away from within and without by the very stars they helped create. Their beauty is temporary, and that makes it even more precious. Over the years, telescopes have returned to this region again and again, each time peeling back another layer. NASA's Chandra X-ray Observatory searched the area for the high-energy signatures of very young stars, but found fewer than expected. That discovery led astronomers to wonder if perhaps the pillar's most active period of star formation had already passed. Chandra's sensitivity to X-rays makes it perfect for detecting newborn stars, since young suns often emit bursts of high-energy radiation. Its quiet reading suggested that many of the stars inside the pillars may already be grown, their nursery gradually falling silent. Yet the story didn't end there. In 2022, nearly 3 decades after Hubble's original image, the James Webb Space Telescope turned its mirrors toward the same region. What it found reignited the wonder. Webb sees an infrared light, capable of piercing through the dust that hides visible starlight. Its view revealed an intricate landscape, newborn stars glowing like embers at the tips of the columns, streams of gas flowing outward, filigree patterns invisible to Hubble's eyes. Where Hubble had shown shape and shadow, Webb showed life, thousands of stars in different stages of becoming. Among them are what astronomers call protostars, young, forming stars still cocooned in gas and dust. A protostar is a promise not yet complete. It hasn't begun nuclear fusion. It glows only from the heat of its own compression. Gravity pulls its particles inward, and friction converts that fall into warmth. Over millions of years, it will grow denser until its core ignites. At that moment, fusion begins, and the protostar becomes a true star, one more point of light added to the universe. Inside the Eagle Nebula, that cycle repeats endlessly. Gas collapses, stars are born, radiation sculpts the gas again, triggering more collapses farther away. It's an ongoing chain reaction of creation, a cosmic nursery singing in wavelengths of light and heat. And though we call them pillars of creation, they are not eternal. The light that Hubble captured left the nebula around 7,000 years ago. What we see might already be gone. Astronomers suspect that a nearby supernova may have blasted through part of the region thousands of years after that light began its journey, perhaps destroying sections of the pillars. But because of the time it takes for light to travel, we won't see that change for another millennium. We are, as always, looking into the past. That is one of the quiet miracles of astronomy. Every photograph is a message from long ago. When we look into space, we see time stretched before us, layered in distance. The pillars of creation are not frozen in eternity. They are a memory still unfolding, their shapes already shifting as their light continues to reach us. Hubble showed us their grandeur. Chandra traced their invisible heat. Webb revealed their hidden stars. Together, these telescopes give us something almost human, a sense of perspective. That everything we build, everything we see, even everything we love, exists within the same fragile impermanence. The The universe makes and unmakes itself constantly, yet in that change lies the purest form of creation. The pillars of creation are both monument and moment. Their beauty lies not in their endurance, but in their transience, the way they hold form just long enough for light to record them. The dust, the gas, the glow, they are physics in motion, but they look like memory, like breath made visible. When you see them, you are seeing the process that made every star, including our sun, and every atom in your body. The calcium in your bones, the carbon in your breath, the iron in your blood, all were forged in stars, like those forming now within the pillars. You are, quite literally, made from the same dust that builds those glowing towers. So perhaps that's why this image moves us so deeply. It's not just beautiful, it's familiar. Somewhere in that distant nursery, the same story that shaped us is still being told. The universe, patient and endless, is still making light from darkness, order from chaos, meaning from motion. And even as those pillars slowly dissolve, their work continues, each particle of dust becoming part of something else, a new star, a planet, a future sky. Nothing in the cosmos truly ends, it only changes form. As we mark the decades since Hubble first revealed the pillars of creation, we're not only celebrating a photograph, we're celebrating the human longing to understand, to see beyond the visible, to look at chaos and find wonder instead of fear. Each new telescope, each sharper image, is another heartbeat in that long pursuit. And one day, when our instruments grow even more sensitive, we will see deeper still, beyond the dust, beyond the visible, into the invisible rhythm that keeps the universe alive. Until then, the pillars of creation remain what they have always been, a luminous whisper from the cosmos, reminding us that every ending carries the shape of a beginning, and every beginning is born from light rising through the dark. That rhythm of beginning, of becoming, never truly stops. It drifts from one corner of the cosmos to another, weaving new worlds from the residue of the old. Between the stars, the universe is not empty. It breathes. It exhales in clouds of gas and dust, the raw material of light. These clouds are called nebulae, vast, delicate veils adrift in darkness. Some are the soft remains of stars that have shed their outer layers. Others are scars from explosions, the shredded edges of supernovae still glowing from the memory of heat. And some, like the one we are about to visit, are the opposite of endings. They are beginnings. A nebula is both a grave and a cradle. It is what happens when the universe pauses between breaths. Gravity pulls its atoms inward, radiation pushes them apart, and somewhere in that tension, stars are born. The Orion Nebula is one of those places, a living workshop of creation glowing faintly in the sword of the constellation Orion. If you've ever looked up on a crisp winter night and seen the familiar shape of Orion, the hunter's belt of 3 stars, in a perfect row, look just below it. There, to the unaided eye, is a faint blur, a subtle patch of light, almost too soft to notice. That is the Orion Nebula, known formally as Messier 42, the closest great star-forming region to Earth. It lies about 1,344 light-years away, within a vast structure of gas and dust called the Orion Molecular Cloud Complex, a region hundreds of light-years wide that hums quietly with the soundless pulse of new stars being born. A nebula may appear dense, but it is almost impossibly thin. The air around you, right now if we can call it that, contains about 10 million trillion molecules in every cubic centimeter. In a nebula, Even the densest parts might contain only a handful of atoms in the same space. It is emptiness sculpted into beauty. But when the ultraviolet light from newly formed stars sweeps across that emptiness, the gas glows. The atoms are ionized, electrons stripped and then recaptured, and with every reunion, light is released. It is like watching invisible music become visible color. The Orion Nebula doesn't just hang quietly in the sky. It moves, breathes, shimmers. It burns like a living cloud, a cavern of violet and rose fire lit from within. Its temperature hovers around 10,000 Kelvin hotter than the surface of our sun, and in its heart, gas and dust swirl in endless motion. Through a telescope, it looks like a storm caught mid-birth. Ribbons of crimson fold through curls of gray-blue. Pockets of darkness twist among bright lanes of light. It is painting and motion at once, a self-creating canvas that never dries. At the nebula's heart is a cluster of stars so bright they can be seen even through the haze, the trapezium cluster. These 4 main stars, all young and massive, shine with a white-blue intensity that floods the nebula. The largest, Theta, to the power of 1 Orionis C, is more than 30 times the mass of the Sun and tens of thousands of times as luminous. It emits torrents of ultraviolet light, stripping electrons from nearby hydrogen atoms. When those electrons rejoin their protons, the gas emits a vivid red glow, known as the H-alpha line. That glow, multiplied across light years of gas, gives the nebula its color, an ocean of rose and crimson, a spectrum of creation. But the light does not spread evenly. Radiation sculpts the gas into hollow chambers, tunnels, and caverns, pushing some regions outward while leaving others untouched. Dark veins of dust wind through it like shadows in smoke. To the eye, they seem to block the light, but they are far more than silhouettes. Inside those cold lanes, gravity is quietly working. Molecules gather, clump, and collapse, until tiny pockets grow dense enough to ignite. Every shadow you see in the Orion Nebula hides a star waiting to be born. Within those folds lies something wondrous: protoplanetary disks, or Proplids, small, flattened rings of gas and dust orbiting new stars. When Hubble first captured them in the 1,990 seconds, astronomers were stunned. Each one is about the size of our solar system. Some already show gaps and ridges carved by baby planets. You can almost imagine the first outlines of worlds, oceans, and moons spinning into being. These tiny disks are laboratories of creation, snapshots of solar systems still assembling. To gaze at them is to look backward in time, to see what our own sun and planets once were, just swirls of dust and light, learning how to hold together. The Orion Nebula is not gentle, though. It's not a nursery in the sense of peace. It's a place of constant conflict, a cosmic forge where energy and matter wrestle for balance. The bright trapezium stars that make the nebula glow are also tearing it apart. Their fierce winds and radiation blast through the cloud, blowing away the gas that once sheltered them. Creation and destruction are happening side by side. It is as if the same hands that build the house are already dismantling its walls. You can see this violence made visible in the Herbig-Haro objects, jets of gas and plasma ejected from forming stars at hundreds of kilometers per second. When these jets slam into surrounding material, they create glowing knots of light, thin and sharp like beams from a distant lighthouse. Through telescopes, they appear almost unreal filaments of electric blue and emerald green arcing through the pink glow. These are the tantrums of infant stars, each jet a sign of something learning how to shine. Everywhere you look, the Orion Nebula is in flux. Waves of energy sweep through it. Shock fronts ripple outward. Entire clouds of gas are being reshaped by the very stars they created. In the language of time, it is fleeting. The nebula we see now will not last long. In just a few million years, a cosmic blink, the gas will disperse, the stars will drift apart, and the great glowing veil will fade into the dark. The Orion Nebula is not a permanent thing. It is a moment of visible heartbeat in the long rhythm of creation. The first humans to record it had no idea what they were looking at. In 1610, Nicolas Claude Fabry de Peiresc was the first to write of its faint shimmer. Nearly 50 years later, Christian Huygens drew it in careful detail, realizing it wasn't a single star, but something wider, more diffuse. Neither could imagine they were looking into a place where stars and planets were being born, where the very building blocks of life were swirling into existence. They simply saw something that didn't fit, and that was enough to keep them looking. Through the lens of time, our understanding has deepened, but the wonder remains the same. Today, we can see the nebula in layers, in optical light, in infrared, in X-rays, and each wavelength reveals a different truth. In visible light, it glows with rose and violet fire. In infrared, as seen by the James Webb Space Telescope, the dust becomes translucent, revealing hundreds of newborn stars previously hidden. In X-rays, captured by Chandra, we see the heat and violence, the chaotic energy at the heart of creation. Together they paint a single truth: this cloud is alive with birth. And yet, what we see is not now. The light that reaches us left the Orion Nebula more than 1,000 years ago. The stars we admire have already changed. Some may have drifted, others brightened or dimmed. We are looking not at the present, but at the ghost of a moment long gone. Astronomy, in this way, is always an act of memory. The sky is a collection of messages sent long before we were here to receive them. Still, the Orion Nebula feels timeless. When you gaze at it, even through a small telescope, it doesn't feel like you're looking at something far away. It feels near, almost personal, as if the light itself remembers the road it took to reach you. The reds from hydrogen, the blues from oxygen, the shadowed threads of dust, they seem to move as you look, a soft illusion of breathing. In those folds and currents, you can see the patterns that shaped our own solar system, the same cosmic grammar that wrote Earth into being. It tells us something profound about beauty and struggle. That creation, in every scale, is never clean. It is messy, loud, fierce. It is collision and heat and pressure, and yet, from that chaos, order emerges. From turbulence comes symmetry, from dust, light. The Orion Nebula reminds us that the universe doesn't produce perfection, it produces life, motion, possibility. Every photon that reaches us from this nebula is proof of that process. Each carries the record of energy turned into form, of gravity and time conspiring to create radiance. And all that light travels through the darkness, not to demand attention, but simply because that is what light does. It moves forward. The Orion Nebula is one of the most beautiful objects in the universe, not just because of its color or shape, but because of what it represents. It is the visible handwriting of creation, the story of how stars learn to shine. It shows us that even in a universe so vast and cold, the act of becoming never ends. The same physics that builds galaxies also builds the cells of your body. The same dust that spins around young stars once formed the atoms that make your breath. Perhaps that's why, when people look at the Orion Nebula, they often feel a quiet familiarity. Somewhere, deep in the structure of our being, we recognize it. We come from places like this. We are its continuation, the children of its dust, the echo of its heat. And as the nebula continues to glow, we are reminded that creation is always unfinished. Each collapse of gas, each flicker of light, each planet forming from dust is part of a story still being written. The Orion Nebula lets us watch that story mid-sentence, caught between one breath and the next. But every light, no matter how young, carries within it the seed of an ending. The stars being born here will one day grow old. Some will swell into red giants, others will explode into supernovae. Their light will scatter across the galaxy, creating new nebulae, new beginnings. The universe never stops changing its form, it only changes its tone. After the bright, fiery chorus of birth comes the quiet music of decline. And so, our journey drifts onward, from the brilliance of a stellar nursery to the slow, dignified light of a star nearing the end of its time. In the stillness of a winter night, when the air feels almost metallic and sound seems to fall away, one star burns with a curious warmth. It doesn't shimmer like the others. It doesn't twinkle or flash. It glows slowly, deeply, like a coal cupped in the dark hand of the sky. You can find it easily if you know where to look. Follow Orion's belt upward to his shoulder, and there, resting low above the horizon, a red flame flickers gently. That is Betelgeuse, the star that breathes. It does not glitter sharply like its companion Rigel, the cold blue beacon at Orion's knee. Betelgeuse carries a different light, soft, smoky, tinged with melancholy. It feels old. Its glow is not the fierce shout of youth, but the quiet hum of memory, a warmth that lingers after fire. Look at it long enough, and you might imagine you can feel it exhale, as if the sky itself is tired, leaning back after an age of burning. Astronomers call it a red supergiant, and that term, though clinical, feels oddly tender. This isn't metaphor, it's fact. Betelgeuse is among the largest and most luminous stars we can see with the naked eye, but it is also nearing the end of its life. Once, millions of years ago, it shone as a brilliant blue-white star, hot and youthful, burning hydrogen in its core. That fuel is gone now. What remains burns slower and heavier. Deep inside, the star is fusing helium into carbon, carbon into oxygen and neon, building shells of ever denser material in layers like an onion. The deeper you go, the faster time moves. That inner labor has swollen Betelgeuse into an impossible scale. If it replaced our sun, its outer edge would reach beyond Mars and nearly to Jupiter, roughly 1.2 billion kilometers across. Its circumference would engulf every planet we know, and yet, though it holds 10 to 20 times the mass of the Sun, it is so distended that its density is barely more than a whisper. The atoms that make up its surface are so far apart that the star's edge is more atmosphere than body. Because it has expanded so greatly, the pull of its own gravity has weakened at the surface. Its outer layers drift in restless motion, rising and falling in enormous convective currents, each cell larger than the orbit of Earth. You could fit our whole solar system inside one of these rolling waves. The star's surface is a landscape of boiling motion, colossal updrafts that carry hot gas upward while cooler material sinks back down. When those currents reach too high, they break free, tossing whole plumes of gas into space, vast, shimmering geysers of matter that drift outward like breath in winter air. Astronomers have seen the aftermath of these tempests. In 1996, the Hubble Space Telescope caught Betelgeuse's face in detail and found it uneven, mottled by bright scars and dark hollows. Later observations confirmed what Hubble had hinted: this star's surface is alive. It shifts, bubbles, and bruises. The ALMA Observatory in Chile later mapped the star's outer atmosphere in unprecedented resolution, revealing arcs of cooler gas curling outward like smoke rings from a cosmic fire. Some patches were hundreds of degrees cooler than the surrounding surface, enormous star spots drifting slowly across its disk. Others were searingly hot, swollen bubbles of light. Betelgeuse's face is never the same twice. This turbulence gives the star a strange rhythm. Its brightness waxes and wanes in long, slow cycles, roughly every 400 days. Those smaller fluctuations ripple within. Astronomers call it a semi-regular variable, but to the naked eye, it simply looks alive. It breathes in light, then releases it. It has been doing so for centuries. Early records from the 1800s describe its shimmering changes, but ancient watchers, Greek, Persian, Chinese, must have seen it too, noticing that the great red star at Orion's shoulder sometimes dimmed as if sighing, then blazed again with renewed strength. And then, not long ago, that breath nearly stopped. In late 2019, Betelgeuse began to dim, slowly at first, then dramatically. Within a few months, it had faded to barely a third of its usual brightness. The once bold ember became a pale, uncertain glow. It dropped from the 11th brightest star in the night sky to the 21st. People all over the world noticed. Astronomers pointed telescopes, students craned their necks, backyard stargazers posted pictures, comparing the changing color night after night. For a brief, breathless moment, humanity wondered if we were witnessing the death of a giant. Headlines everywhere asked the same question: is Betelgeuse about to explode? The thought was electric. A supernova in our lifetime, visible in daylight, bright enough to cast shadows at night, an event so rare it hasn't happened this close to Earth for hundreds of thousands of years. The idea felt mythic. After all, this was Orion's shoulder, the red heart of winter skies. What would the hunter look like without his flame? The event came to be known as the Great Dimming, and for months the astronomical world held its breath. But by the early months of 2020, the star began to recover. Its light slowly brightened, deepening once more into its familiar copper-red hue. When the data came in, the truth turned out stranger, and in a way gentler than the myth. Betelgeuse hadn't died at all. What had happened was a colossal eruption. A huge portion of the star's outer atmosphere had burst outward, flung into space by one of those convective storms. The expelled gas cooled as it drifted, condensing into a cloud of dust. That dust passed between Earth and the star, dimming its light like a veil drawn across a lantern. What we saw was not death, but a pause, a celestial exhale that briefly shadowed the glow. Still, the message lingered. Betelgeuse is old. It is fragile. Its structure trembles with age and imbalance. The star is burning through the last reserves of its fuel, building heavier elements in its core: carbon, neon, magnesium, silicon, and finally, iron. When the iron forms, fusion will cease, for iron resists transformation. The furnace will stall. In that instant, the outward push that has balanced gravity for millions of years will vanish. The weight of the outer layers will fall inward, collapsing toward the core faster than thought. Then comes the rebound. A shock wave will tear outward through the star's body. flinging its layers into space at 1/10 of the speed of light. The entire star will explode in a blaze of unimaginable brightness, a Type II supernova. When that day arrives, the night will not be dark. For a time, Betelgeuse will outshine the full moon. Its light will be visible even in daylight. The familiar red shoulder of Orion will become a beacon of white fire. People across Earth will look up and see a new sun where once there was only a star. The explosion will last weeks or months, its brightness slowly fading as the debris cools and expands. And then, from that chaos, something smaller will remain. If Betelgeuse's final mass lies below a certain threshold, its core will stabilize as a neutron star, a sphere barely 20 kilometers across, spinning hundreds of times per second, sending pulses of radiation into the cosmos. If it is heavier, gravity will win entirely, crushing the core into a black hole, an invisible scar in space-time from which no light escapes. Either way, what survives will be tiny compared to the vast body we see today, but the space around it will not be empty. The explosion will scatter its elements, iron, silicon, oxygen, carbon, through interstellar space. That material will drift for millions of years, mixing with other clouds until gravity gathers it again. Out of that mixture, new stars will form. Around those stars, new worlds. And one day, on one of those worlds, perhaps something with eyes will look up and wonder about the red light that came before. That is the true immortality of stars. They die, but they do not end. Their ashes become everything. The iron in your blood, the oxygen in your breath, the calcium in your bones, all of it was forged in the death of stars like Betelgeuse. We carry their remnants inside us. Every heartbeat is a memory of fire. So when you look up at Betelgeuse, know that you are seeing not just a star, but a mirror. Its slow pulse is your own, written on a cosmic scale. It is the soundless rhythm of transformation, matter becoming light, light becoming matter again. The name Betelgeuse comes from the Arabic Yad al-Jawza, the hand of Orion, passed down through centuries of watching and retelling. It has been recorded in ancient Greek and Islamic texts, marked on maps of the heavens long before telescopes existed. For millennia, people have stood in the chill of winter and looked up at that red glow, weaving stories around it, never realizing they were watching a giant slowly exhale the last of its life. Now, we know what they could not. We know that inside that glow lies a furnace of collapsing layers and failing pressure, a body vast enough to swallow worlds, trembling on the edge of its own undoing. And yet, knowing doesn't diminish its beauty, it deepens it. There is something profoundly human about the way Betelgeuse shines, not steady, not perfect, but full of motion and imperfection. Each flicker of its light is a confession. I am still here. The photons reaching your eyes tonight began their journey 600 years ago. They left the star before telescopes, before electricity, before the world as we know it. Those photons have crossed centuries in silence to arrive at this very moment. You are seeing ancient light, a ghost of what was. Perhaps Betelgeuse has already changed, perhaps even ended, but we will not know for generations. The sky teaches patience. Maybe that's why watching Betelgeuse feels so intimate. Its red light doesn't dazzle, it lingers, like a candle at the edge of sleep. It is both reminder and promise that endings are not failures, and that even decay can shine. One night, perhaps soon, perhaps long after we are gone, Betelgeuse will burst into brilliance. The night will fill with color. Then, when its fire fades, a cloud will remain a glowing ring of gas expanding outward, carrying its story into the dark. From that dust, new beginnings will rise. The Orion Nebula, young and bright, burns nearby in the same constellation. Together, these two form the full cycle of existence, birth and death, side by side in the sky. One glows with the fierce energy of creation, the other with the quiet beauty of release. The same cosmic breath moves through them both. If the Orion Nebula is the universe's first cry, then Betelgeuse is its sigh, a long, warm exhalation, gentle and inevitable. It is the moment when light loosens its hold and becomes memory. And sometimes, after the breath has faded, something unexpected lingers, not a blaze, not a star, but an eye, a soft, luminous ring expanding into silence, watching. That is where we go next, to the Helix Nebula, the Eye of God, where the last breath of a dying star becomes the gaze of eternity. Once you know where to look, it's impossible to forget. In the quiet southern sky, just below the constellation Aquarius, there lingers a shape so haunting, so deliberate in its stillness, that for centuries people have called it the Eye of God. Its formal name is NGC 7293, but most know it as the Helix Nebula. It lies only about 655 light-years away, cosmically speaking, a neighbor close enough that its faint radiance can reach us with minimal distortion. It is one of the nearest planetary nebulae ever discovered, and when you look at it through a telescope, it looks back. What you see isn't an illusion. The Helix Nebula truly resembles an eye gazing outward from the dark, an iris of gas, color, and light suspended in silence. At its center glows a soft blue circle, cool and electric, surrounded by spiraling rings of green, amber, and faint crimson. The colors do not blend like paint. They layer and ripple, one within another, as though light itself were breathing. The shape isn't the vast whirl of a galaxy, nor the chaotic dust clouds of a stellar nursery. It is something quieter, more intimate, the slow unraveling of a single star's life. The helix marks the death of a sun-like star, one that once burned with the same golden calm as our own. For nearly 10 billion years, that star lived in equilibrium, fusing hydrogen into helium in its core. It balanced gravity's pull inward with the pressure of radiation pushing outward. But even the most stable fires run out of fuel. When the hydrogen finally depleted, the core contracted and heated, igniting new layers of fusion farther out. The outer shell swelled, and the star transformed into a red giant, growing hundreds of times larger than the Sunday. For a while, it lived in that grand, unstable form, its atmosphere tenuous, its heart flickering. And then, slowly, it began to shed itself. The end didn't come with a single explosion. It came in waves, as if the star couldn't quite let go. Over tens of thousands of years, it released its outer layers in gentle pulses, thin shells of gas expanding outward into the dark. The remains of those layers are what we now see as the Helix Nebula, an expanding halo of gas and plasma, about 2.5 light-years across, a sphere so large that light itself takes years to cross it. At its center lies the survivor, the final ember, a white dwarf, roughly the size of Earth but containing about 60% of the Sun's mass. Its density is almost unimaginable. A teaspoon of its matter would weigh several tons, no longer fusing atoms. It glows only from residual heat, its surface temperature exceeding 100,000 Kelvin, hot enough to vaporize anything nearby. Over billions of years, it will cool and fade into darkness becoming what astronomers call a black dwarf, though the universe itself is still too young for any to exist. The white dwarf's ultraviolet radiation is what makes the Helix Nebula visible at all. It energizes the atoms of the surrounding gas, stripping electrons from them. When those electrons recombine, they release light at precise wavelengths. Doubly ionized oxygen gives the nebula its blue-green center. Hydrogen glows soft red. Nitrogen adds strokes of orange and carmine. The result is a cosmic watercolor, color by chemistry, shape by memory. Every photon you see was once trapped inside a star, now free to drift. From Earth, the helix looks still, but it's alive with motion. The gases are expanding outward at about 32 kilometers per second, rippling into the interstellar medium. Over the next few thousand years, the rings will thin, their edges will blur, and the entire structure will dissolve into the wider galaxy. For now, though, the nebula remains beautifully coherent, a frozen breath in the middle of exhalation. Look closer, Hubble did, in 1996, and the Serenity breaks apart into astonishing detail. The rings are not smooth but dimpled with knots, tiny, dense clumps of gas and dust scattered throughout the nebula like seeds. Astronomers call them cometary knots, though they are far larger than comets, each roughly 100 billion kilometers across, nearly the size of our solar system. They have bright, rounded heads and faint trailing tails, always pointing away from the central star, shaped by the radiation pressure of the white dwarf's fierce light. These knots are fragile things, sculpted by competing forces. Ultraviolet light strips them of material, while internal density tries to hold them together. They appear frozen, but in truth, they are evaporating slowly, imperceptibly, their gases fading into space. Thousands of them drift through the nebula, each with its own contour, its own shadow. Some are tightly packed, shielding their interiors from radiation, dark islands in a glowing sea. Others are transparent ghosts, their structure dissolving, their light fading. If you could fly among them, it would be like sailing through a mist made of time. The story of how these layers formed is one of wind against wind. In its last stages, the dying star exhaled gas at different speeds. The first winds, during the red giant phase, were slow and steady, 10 kilometers per second, a patient drift. Later, as the core shrank into a white dwarf, faster winds emerged over 100 kilometers per second. The fast winds overtook the slow ones, colliding with them and compressing the gas into concentric shells. Each shell marks a rhythm of release, a note in the long song of the star's death. The Helix Nebula is that song made visible, shock fronts frozen into rings, layers of memory orbiting an absent heart. And yet, despite its name, this nebula has nothing to do with planets. The term planetary nebula was coined by early astronomers in the 18th century, people like William Herschel, who, peering through modest telescopes, saw glowing disks that looked round and smooth, like tiny planets. They couldn't yet see the filaments and folds within, the evidence of decay. The name stuck, a linguistic fossil from an age of wonder. But these nebulae are not planetary. They are funerary death, masks of stars, glowing tombs made of the matter they once contained. The Helix Nebula was first recorded in the 1820 seconds by German astronomer Carl Ludwig Harding, who saw it as a faint, ghostly ring near Aquarius. Over the 19th and 20th centuries, as telescopes improved, its true nature came into focus. It became not just an object of beauty, but a laboratory, a nearby window into the fate awaiting our own Sunday. Because that is what makes the helix so haunting. It is a mirror of our future. Billions of years from now, our sun will exhaust its hydrogen, expand into a red giant, and shed its outer layers just as this star did. Earth will be swallowed, reduced to vapor. The sun's remaining core will shrink into a white dwarf, glowing pale blue at first, then dimming slowly across eons. Around it will hang a mist of color, a planetary nebula, faint but beautiful. If there are any eyes left to see it, they will look upon a smaller version of this cosmic eye. The eye of God is, in truth, the eye of destiny. To observe it is to look both outward and forward, to see, in one glance, the death of another star and the prophecy of our own. But the helix isn't only an emblem of ending. It's a testament to how endings shape what follows. The gases flowing outward from the star are rich with carbon, oxygen, nitrogen elements forged in its final moments of fusion. When those gases disperse into the galaxy, they enrich interstellar space, making future worlds possible. Every molecule of water, every breath of air, every leaf and lung on Earth owes its atoms to such nebulae. Without them, there would be no chemistry, no life. The helix is not the end of creation, it's part of its continuation. If you were to watch it unfold in time-lapse over millennia, you would see the eye blink. The inner glow would fade first, the outer halo next, until only darkness remained. The white dwarf at its core would continue shining faintly, gradually cooling over billions of years. Long after its light disappears, the elements it released will still drift among the stars, ready to be gathered once more. That cycle, the breathing of the cosmos, is perhaps the most beautiful idea in all of astronomy, that the universe never wastes itself. Everything that exists is recycled. Every atom has been elsewhere, inside other stars, part of other skies. The carbon that forms your brain, the calcium in your bones, the iron in your blood, all of it once belonged to stars like the one that made the Helix Nebula. We are made from the remains of the dead, and through us, the universe continues to know itself. When you gaze at the helix through a telescope, the first impression is peace. It feels almost sacred, as though you're looking into something that's both vast and personal. Its symmetry invites stillness. Yet when you look longer, the peace dissolves into complexity. The concentric rings ripple with turbulence. The cometary knots flicker like embers in the wind. Nothing is static. Even the calmest scene in the cosmos is motion disguised as rest. And still, the emotion that lingers is calm. Not because the nebula is unchanging, but because its change is so slow, so measured, that it feels eternal. It is the kind of beauty that invites silence. A beauty that doesn't shout, but hums quietly in the back of the mind. Astronomers estimate that the Helix Nebula is only about 10,000 years old, a newborn ghost in cosmic time. In another 20,000 years or so, its glow will have faded, its gases blended with the background of the Milky Way. The eye of God will close. But for now, we are lucky enough to see it mid-breath, the last luminous sigh of a star that once burned like our own. Imagine standing somewhere on a distant world, orbiting another sun, looking up and seeing your star dying in this way. Imagine knowing that its final breath will one day feed new stars, new worlds. Would you feel sadness or awe? Maybe both. The Helix Nebula holds that contradiction perfectly. It is both grave and cradle, elegy and promise. It shows us that endings are not the opposite of beginnings, but their necessary companions. The death of one star becomes the light of countless others. The eye of God is not watching us from above. It is showing us what we are made of and what we will become. From a distance, its gaze feels eternal. But move closer in thought, and you realize it's fleeting, a single blink in the lifespan of the galaxy. The photons that left its glowing gas thousands of years ago are only now reaching your eyes. By the time your great-grandchildren's great-grandchildren look up, the nebula will already be different. Every glance at the sky is a message from the past. Perhaps that's what makes this nebula feel so human. It looks like an eye, and it behaves like memory. It holds light that once belonged to something that no longer exists. And yet, through that light, it continues to be seen, to be known. In the end, all stars share this fate. Whether they end as white dwarfs, neutron stars, or black holes, they leave behind something that outlives them. A trace, a whisper, a piece of themselves still shining. The Helix Nebula is that whisper given form. It is the universe remembering itself. And as we drift from this quiet vision, this glowing iris in the dark, we carry its lesson with us. That beauty can exist in decay, and that even the final breath of a dying sun can light up the void. We have followed the story of stars from their birth to their death, from the nurseries of Orion to the old red flame of Betelgeuse, and now to this gentle, fading eye. But there is one more chapter to follow. What happens when there is no star at all? No light to shape the dark, no warmth to resist collapse. What happens when gravity wins entirely, and even memory disappears into silence? Beyond the glow of nebulae, beyond the whispers of dying suns, lies something deeper still. A place not made of presence, but of absence. A hole in the very structure of the cosmos. There is a kind of beauty that doesn't shine. It doesn't flicker like a candle or shimmer like frost on glass. It doesn't swirl like a galaxy or blaze with the fever of a star. It simply waits quiet, immense, and unmoving. It is the beauty of absence, of space stripped bare of everything that usually defines it. That is the beauty of the Botis void, a silence so perfect it feels deliberate, as if the universe sculpted stillness itself and left it there for us to find. This is not the kind of wonder that dazzles the eyes. It's the kind that humbles the mind. When it was first discovered in 1981 by Robert Kirshner and his team at the Harvard-Smithsonian Center for Astrophysics, astronomers weren't even looking for beauty. They were building a map of the universe, a three-dimensional survey based on redshift data, measuring how galaxies move as the universe expands. Instead of light through a telescope, they were working with numbers, the fingerprints of galaxies receding from us, the stretching of their wavelengths into the red part of the spectrum. When those points were plotted on a cosmic chart, one region stood out not because it gleamed, but because it didn't. A vast, nearly featureless patch of space, over 300 million light-years across, where galaxies were almost entirely missing. To understand what that means, picture this. If our Milky Way galaxy sat at the center of that void, you would have to travel 150 million light-years in any direction before reaching the next crowded region of space. The Milky Way itself is only about 100,000 light-years wide, a speck compared to the chasm of the Boetis void. In a typical part of the universe, a volume this large should host tens of thousands of galaxies, each with hundreds of billions of stars. Yet in this particular expanse, scientists have found fewer than 60 known galaxies, 60 specks of light, adrift in a darkness so complete that it feels less like space and more like silence given form. The void isn't spherical or tidy. It's irregular, like a scar worn into the fabric of the cosmos. an immense hollow roughly shaped like a crater rather than a bubble. When plotted in 3 dimensions, it appears like a cavern, a gap inside the intricate web of galaxies, gas, and dark matter that we now know forms the skeleton of the universe. Astronomers call this pattern the cosmic web, a vast network of filaments and nodes stretching across billions of light years. Galaxies are not scattered randomly through space. They are woven along these filaments, clumping at the intersections, leaving enormous hollow regions between them. The Boötes Void is one of the largest of those hollows, a cosmic basin where almost nothing ever gathered. When it was first identified, this emptiness confounded cosmologists. In the early 1980s, the reigning model of structure formation was based on the concept of cold dark matter, a form of matter invisible to light but crucial to the gravitational scaffolding that binds galaxies together. Simulations based on that model predicted voids, yes, but not one this vast, and certainly not this empty. The Boötes Void didn't fit. It was too extreme, too barren. It was like mapping a forest and finding, right in the middle, a missing continent. A place so big and so blank that it seemed to mock the models meant to explain it. To make sense of this strange vacancy, scientists proposed the void merger hypothesis. The idea was that the Boötes Void didn't start as a single, massive hollow, but grew from the merging of many smaller ones. In the early universe, space was like a patchwork of slightly denser and slightly emptier regions, tiny wrinkles in the cosmic fabric. As time passed, matter drifted from the less dense regions toward the more crowded ones, where gravity pulled harder. The emptier zones expanded, the denser ones condensed, and some neighboring voids gradually merged, coalescing into a single vast expanse. Over billions of years, those pockets of nothingness may have fused, like soap bubbles joining in slow motion, swelling as the universe stretched. That process was likely helped along by dark energy, the mysterious force that accelerates cosmic expansion. Around 5 billion years ago, dark energy began to dominate the universe's evolution, pushing galaxies farther apart and amplifying the gaps between them. If the Boötes Void was once a cluster of smaller voids, dark energy may have inflated their boundaries until they blended into one. What we see now could be a compound void, a cathedral of nothing, built by the universe's steady exhalation. But not everyone was convinced by this late-time explanation. Some cosmologists suggested something even more haunting, that the Boötes Void may be primordial, a relic from the universe's first instant. In this view, the void didn't emerge from the slow migration of galaxies. It was there from the beginning, a fossil of creation, etched into the universe before the first stars ever lit. To understand this, we have to look back to the Big Bang and the brief moment of cosmic inflation that followed. In that infinitesimal fraction of a second, around 10^3,610, -36, 1036 seconds after time began, the universe expanded faster than light, ballooning from subatomic to cosmic scale. During that process, tiny quantum fluctuations, microscopic ripples in energy density, were stretched into vast structures. Some regions ended up slightly denser, others slightly emptier. Over billions of years, the denser spots became galaxies and clusters, while the emptier ones became voids. If this is true, then the Boötes Void may be one of those ancient underdensities, a direct descendant of the universe's earliest structure, a place that has been almost empty for 13.8 billion years. Evidence for these ancient imprints appears in the cosmic microwave background, the faint afterglow of the Big Bang. Satellites like COBE, WMAP, and Planck have mapped the CMB in extraordinary detail, revealing faint variations in temperature that match the pattern of today's galaxies and voids. The Boötes void might therefore be a macrocosmic echo of those early fluctuations, a memory of the universe before form. There is a strange kind of poetry in that a silence so deep it might be older than stars themselves. For most of us, the word space already means emptiness, but the cosmos is far from truly empty. Even its darkest regions hum faintly with structure. Galaxies align along filaments. Gravity binds them at nodes, and thin clouds of hydrogen gas thread through the gaps. The universe resembles a vast foam, clusters and superclusters forming the bubble's edges, while the voids are the spaces between. Even the most barren regions contain diffuse gas, dark matter halos, or the occasional dwarf galaxy, a dim ember adrift in the dark. But the Boötes void is different. It is not just underpopulated, it is profoundly empty, a space so clean that its very existence reshaped how scientists understood the distribution of matter on cosmic scales. And yet, emptiness is not the same as irrelevance. The Boötes void still exerts gravitational influence not through presence, but through contrast. Denser regions of the universe pull more strongly, so galaxies near the void's edge feel a net tug outward, drawn toward richer, heavier clusters. This creates what astronomers call peculiar velocity motion, not caused by the overall expansion of space, but by local imbalances in gravity. Over time, galaxies slide away from the void's center, leaving it even emptier. It's like watching water drain from a well, the surrounding flow deepening the hollow. These flows aren't just beautiful, they're useful. By measuring the movement of galaxies around voids like Boötes, astronomers can study cosmic flows, the grand migration of matter through the universe. Such observations help refine models of dark matter distribution, void evolution, and even the nature of dark energy itself. When combined with computer simulations, they reveal that voids aren't static holes, they're dynamic, expanding structures that grow as the universe ages. Each one is a fingerprint of gravity and time working in opposite directions, gravity trying to pull matter in, dark energy pushing everything apart. In recent years, deep sky surveys, like the Sloan Digital Sky Survey, SDSS, and the 2DF Galaxy Redshift Survey, have mapped thousands of cosmic voids, creating a more complete picture of the large-scale structure of the cosmos. The Boötes void remains among the largest, but it's no longer unique. It's part of a hierarchy of emptiness, some small as the distance between galaxies, others stretching nearly 1 billion light-years across. These voids, taken together, account for about 80% of the observable universe's volume. Most of the cosmos, it turns out, is not filled with stars or galaxies, but with silence. Inside the Boötes void, the few galaxies that do exist live unusual lives. Cut off from the gravitational company of neighbors, they evolve in solitude. Without collisions or mergers to stir them, their shapes remain delicate, their star formation slow. Some are faint spiral galaxies, quietly turning. Others are ellipticals, their gas long depleted. They are survivors in an environment of almost total absence. Astronomers have even used simulations to study what a night sky might look like from within one of these lonely systems. There would be no Milky Way-like band overhead, no crowded constellations, just a sparse scattering of faint points and a depth of black so complete that it would seem bottomless. This deep quiet has consequences. When photons from the cosmic microwave background pass through the Botez void, they experience a subtle energy shift due to the evolving gravitational potential within the void. This effect, known as the integrated Sachs-Wolf effect, is one of the few ways to measure the influence of dark energy directly. By stacking data from many voids, scientists can detect minute temperature differences in the CMB and test how the expansion of space accelerates over time. Even nothing, it turns out, can be measured, and it can speak. The Botez void has become more than a curiosity. It's a key part of cosmological research. Its structure helps confirm the predictions of the lambda cold dark matter model, the leading theory of the universe's composition and evolution. It also provides a testing ground for alternative ideas, whether gravity behaves differently on cosmic scales or whether dark energy might vary in strength across space. By studying the shape, density, and motion of galaxies near the void's edge, scientists learn how space-time curves and stretches in places where almost nothing resides. But beyond equations and simulations, there's something almost meditative about this hollow. The Botez void is not a flaw or an accident. It's a reminder that absence is part of design. The universe does not fill every corner with light because contrast gives meaning. Stars are visible because the sky is dark. Galaxies are defined because space between them is vast. The Botez void is the cosmic punctuation that lets the sentence of existence breathe. The name itself carries a small story. Botez refers to the northern constellation known as the Herdsman, home to the bright star Arcturus. But the word echoes boot, a step, a tread. And indeed, it feels as though the universe pressed its heel into the fabric of space and left a footprint that never filled back in. That image feels right. The void is not an erasure, but an impression, a memory of movement, a mark that says something passed through here, and in its passing, left silence behind. Over time, astronomers have found that voids like Botez aren't truly empty, but dynamic. They expand, stretch, and shift as the universe evolves. Galaxies at their borders move outward, while dark matter within thins and smooths. Some models even suggest that voids will one day merge into supervoids, creating regions so large they could span a significant fraction of the observable universe. In that far future, billions of years from now, the cosmic web may look even more skeletal filaments, thinner, clusters, more isolated, and the voids between them vast beyond imagining. If you could somehow drift to the center of the Botez void, float in a spacecraft in its deepest heart, you would see a darkness unlike any other. The background glow of galaxies would be faint, the cosmic microwave background nearly uniform from every direction. There would be no up or down, no orientation, just the slow, expanding quiet of space itself. It would feel less like being lost than like being freed from reference, a sense of peace born from total stillness. The Botez void, then, is not a void at all in the human sense. It is not desolation, it is balance. It is the universe at rest between breaths. Through it, we see that emptiness has structure, that nothingness is not disorder, but another form of pattern. The cosmic web depends on these spaces of silence, just as a melody depends on pauses. Without the Botez void and its kin, the universe would be nothing but noise, a blur of constant brightness, without contrast, without meaning. So this great hollow, this cathedral of quiet, is not a mistake. it is a reminder. It tells us that beauty can exist without light, that order can arise from absence, that silence itself is part of the song. After peering into the Botez void, even the smallest glimmer seems sharper. The smallest symmetry feels sacred. Because when you've seen how vast nothing can be, you begin to notice how astonishing it is that anything exists at all. There is a kind of beauty that doesn't shine. It doesn't flicker like a candle or shimmer like frost on glass. It doesn't swirl like a galaxy or blaze with the fever of a star. It simply waits quiet, immense, and unmoving. It is the beauty of absence, of space stripped bare of everything that usually defines it. That is the beauty of the Botez void, a silence so perfect it feels deliberate, as if the universe sculpted stillness itself and left it there for us to find. This is not the kind of wonder that dazzles the eyes, it's the kind that humbles the mind. When it was first discovered in 1981 by Robert Kirshner and his team at the Harvard-Smithsonian Center for Astrophysics, astronomers weren't even looking for beauty. They were building a map of the universe, a three-dimensional survey based on redshift data, measuring how galaxies move as the universe expands. Instead of light through a telescope, they were working with numbers, the fingerprints of galaxies receding from us, the stretching of their wavelengths into the red part of the spectrum. When those points were plotted on a cosmic chart, one region stood out not because it gleamed, but because it didn't. A vast, nearly featureless patch of space, over 300 million light-years across, where galaxies were almost entirely missing. To understand what that means, picture this. If our Milky Way galaxy sat at the center of that void, you would have to travel 150 million light-years in any direction before reaching the next crowded region of space. The Milky Way itself is only about 100,000 light-years wide, a speck compared to the chasm of the Botez void. In a typical part of the universe, a volume this large should host tens of thousands of galaxies, each with hundreds of billions of stars. Yet in this particular expanse, scientists have found fewer than 60 known galaxies. 60 specks of light adrift in a darkness so complete that it feels less like space and more like silence given form. The void isn't spherical or tidy. It's irregular, like a scar worn into the fabric of the cosmos, an immense hollow roughly shaped like a crater rather than a bubble. When plotted in 3 dimensions, it appears like a cavern, a gap inside the intricate web of galaxies, gas, and dark matter that we now know forms the skeleton of the universe. Astronomers call this pattern the cosmic web, a vast network of filaments and nodes stretching across billions of light-years. Galaxies are not scattered randomly through space. They are woven along these filaments, clumping at the intersections, leaving enormous hollow regions between them. The Botez void is one of the largest of those hollows, a cosmic basin where almost nothing ever gathered. When it was first identified, this emptiness confounded cosmologists. In the early 1980 seconds, the reigning model of structure formation was based on the concept of cold, dark matter, a form of matter invisible to light, but crucial to the gravitational scaffolding that binds galaxies together. Simulations based on that model predicted voids, yes, but not one this vast, and certainly not this empty. The Botez void didn't fit. It was too extreme, too barren. It was like mapping a forest and finding, right in the middle, a missing continent, a place so big and so blank that it seemed to mock the models meant to explain it. To make sense of this strange vacancy, scientists proposed the void merger hypothesis. The idea was that the Boötes void didn't start as a single, massive hollow, but grew from the merging of many smaller ones. In the early universe, space was like a patchwork of slightly denser and slightly emptier regions, tiny wrinkles in the cosmic fabric. As time passed, matter drifted from the less dense regions toward the more crowded ones, where gravity pulled harder. The emptier zones expanded, the denser ones condensed, and some neighboring voids gradually merged, coalescing into a single vast expanse. Over billions of years, those pockets of nothingness may have fused like soap bubbles, joining in slow motion, swelling as the universe stretched. That process was likely helped along by dark energy, the mysterious force that accelerates cosmic expansion. Around 5 billion years ago, dark energy began to dominate the universe's evolution, pushing galaxies farther apart and amplifying the gaps between them. If the Boötes void was once a cluster of smaller voids, dark energy may have inflated their boundaries until they blended into one. What we see now could be a compound void, a cathedral of nothing, built by the universe's steady exhalation. But not everyone was convinced by this late-time explanation. Some cosmologists suggested something even more haunting, that the Boötes void may be primordial, a relic from the universe's first instant. In this view, the void didn't emerge from the slow migration of galaxies. It was there from the beginning, a fossil of creation etched into the universe before the first stars ever lit. To understand this, we have to look back to the Big Bang and the brief moment of cosmic inflation that followed. In that infinitesimal fraction of a second around 1036 seconds after time began, the universe expanded faster than light, ballooning from subatomic to cosmic scale. During that process, tiny quantum fluctuations, microscopic ripples in energy density, were stretched into vast structures. Some regions ended up slightly denser, others slightly emptier. Over billions of years, the denser spots became galaxies and clusters, while the emptier ones became voids. If this is true, then the Boötes void may be one of those ancient underdensities, a direct descendant of the universe's earliest structure, a place that has been almost empty for 13.8 billion years. Evidence for these ancient imprints appears in the cosmic microwave background, the faint afterglow of the Big Bang. Satellites like COBE, WMAP, and Planck have mapped the CMB in extraordinary detail, revealing faint variations in temperature that match the pattern of today's galaxies and voids. The Boötes void might therefore be a macrocosmic echo of those early fluctuations, a memory of the universe before form. There is a strange kind of poetry in that a silence so deep it might be older than stars themselves. For most of us, the word space already means emptiness, but the cosmos is far from truly empty. Even its darkest regions hum faintly with structure. Galaxies align along filaments. Gravity binds them at nodes, and thin clouds of hydrogen gas thread through the gaps. The universe resembles a vast foam clusters and superclusters forming the bubble's edges, while the voids are the spaces between. Even the most barren regions contain diffuse gas, dark matter halos, or the occasional dwarf galaxy, a dim ember adrift in the dark. But the Boötes void is different. It is not just underpopulated, it is profoundly empty, a space so clean that its very existence reshaped how scientists understood the distribution of matter on cosmic scales. And yet, emptiness is not the same as irrelevance. The Boötes void still exerts gravitational influence, not through presence, but through contrast. denser regions of the universe pull more strongly, so galaxies near the void's edge feel a net tug outward, drawn toward richer, heavier clusters. This creates what astronomers call peculiar velocity motion, not caused by the overall expansion of space, but by local imbalances in gravity. Over time, galaxies slide away from the void's center, leaving it even emptier. It's like watching water drain from a well, the surrounding flow deepening the hollow. These flows aren't just beautiful, they're useful. By measuring the movement of galaxies around voids like Boötis, astronomers can study cosmic flows, the grand migration of matter through the universe. Such observations help refine models of dark matter distribution, void evolution, and even the nature of dark energy itself. When combined with computer simulations, they reveal that voids aren't static holes, they're dynamic, expanding structures that grow as the universe ages. Each one is a fingerprint of gravity and time working in opposite directions. Gravity trying to pull matter in, dark energy pushing everything apart. In recent years, deep sky surveys, like the Sloan Digital Sky Survey, SDSS, and the 2DF Galaxy Redshift Survey, have mapped thousands of cosmic voids, creating a more complete picture of the large-scale structure of the cosmos. The Boötis void remains among the largest, but it's no longer unique. It's part of a hierarchy of emptiness, some small as the distance between galaxies, others stretching nearly 1 billion light-years across. These voids, taken together, account for about 80% of the observable universe's volume. Most of the cosmos, it turns out, is not filled with stars or galaxies, but with silence. Inside the Boötis void, the few galaxies that do exist live unusual lives. Cut off from the gravitational company of neighbors, they evolve in solitude. Without collisions or mergers to stir them, their shapes remain delicate, their star formations slow. Some are faint spiral galaxies, quietly turning. Others are ellipticals, their gas long depleted. They are survivors in an environment of almost total absence. Astronomers have even used simulations to study what a night sky might look like from within one of these lonely systems. There would be no Milky Way-like band overhead, no crowded constellations, just a sparse scattering of faint points and a depth of black so complete that it would seem bottomless. This deep quiet has consequences. When photons from the cosmic microwave background pass through the Boötis void, they experience a subtle energy shift due to the evolving gravitational potential within the void. This effect, known as the integrated Sachs-Wolf effect, is one of the few ways to measure the influence of dark energy directly. By stacking data from many voids, scientists can detect minute temperature differences in the CMB and test how the expansion of space accelerates over time. Even nothing, it turns out, can be measured, and it can speak. The Boötis void has become more than a curiosity. It's a key part of cosmological research. Its structure helps confirm the predictions of the lambda cold dark matter model, the leading theory of the universe composition and evolution. It also provides a testing ground for alternative ideas, whether gravity behaves differently on cosmic scales or whether dark energy might vary in strength across space. By studying the shape, density, and motion of galaxies near the void's edge, scientists learn how space-time curves and stretches in places where almost nothing resides. But beyond equations and simulations, there's something almost meditative about this hollow. The Boötis void is not a flaw or an accident, it's a reminder that absence is part of design. The universe does not fill every corner with light, because contrast gives meaning. Stars are visible because the sky is dark. Galaxies are defined because space between them is vast. The Botez void is the cosmic punctuation that lets the sentence of existence breathe. The name itself carries a small story. Botez refers to the northern constellation known as the Herdsman, home to the bright star Arcturus. But the word echoes boot, a step, a tread. And indeed, it feels as though the universe pressed its heel into the fabric of space and left a footprint that never filled back in. That image feels right. The void is not an erasure, but an impression, a memory of movement, a mark that says something passed through here, and in its passing left silence behind. Over time, astronomers have found that voids like Boötes aren't truly empty, but dynamic. They expand, stretch, and shift as the universe evolves. Galaxies at their borders move outward, while dark matter within thins and smooths. Some models even suggest that voids will one day merge into supervoids, creating regions so large they could span a significant fraction of the observable universe. In that far future, billions of years from now, the cosmic web may look even more skeletal, filaments thinner, clusters more isolated, and the voids between them vast beyond imagining. If you could somehow drift to the center of the Botez void, float in a spacecraft in its deepest heart, you would see a darkness unlike any other. The background glow of galaxies would be faint, the cosmic microwave background nearly uniform from every direction. There would be no up or down, no orientation, just the slow, expanding quiet of space itself. It would feel less like being lost than like being freed from reference, a sense of peace born from total stillness. The Botez void, then, is not a void at all in the human sense. It is not desolation. It is balance. It is the universe at rest between breaths. Through it, we see that emptiness has structure, that nothingness is not disorder but another form of pattern. The cosmic web depends on these spaces of silence, just as a melody depends on pauses. Without the Botez void and its kin, the universe would be nothing but noise, a blur of constant brightness, without contrast, without meaning. So this great hollow, this cathedral of quiet, is not a mistake. It is a reminder. It tells us that beauty can exist without light, that order can arise from absence, that silence itself is part of the song. After peering into the Botez void, even the smallest glimmer seems sharper. The smallest symmetry feels sacred. Because when you've seen how vast nothing can be, you begin to notice how astonishing it is that anything exists at all. The quiet holds. Not the kind that erases, but the kind that carries like the hush between heartbeats. Like the pause in a lullaby where the note waits to return. From that weightless center, where directions fall away and the dark is perfectly even, we begin to drift. Not outward or inward, only along the simple current of being here, together, with the lights dimming and the universe breathing its long, patient breath. Let the mind rest against that balance. Let the eyes soften. Somewhere far beyond the roofline, beyond the last noise of the day, the great lattice of space keeps its silent patterns. What was bright has gentled, what was distant has grown kind. Even memory loosens its knot a little, and you can set it down beside you, like a coat on the back of a chair, and feel how light the body is when it has nothing more to carry. If a star were to speak, it would not use words, only warmth. If a nebula were to sing, it would do it by opening and closing, slow as a tide. And if a great hollow of space were to teach, it would offer only quiet, the way a night window offers the shape of a tree. You do not need to hold any of it. It holds you. The mind can float like a small boat in still water, a soft tether untying, the shore gently receding, the oars tucked beneath your hands and forgotten. The day's edges fade, the long thoughts fold themselves neatly away. You can feel the room exhale along with you, curtains settling, air cooling, the gentle hush that follows the last footstep in the hallway. Above that hush, the thin seam of sky glows and then dims, like an ember, deciding not to rise again. So much of the universe is a conversation between light and its own shadow. Tonight, you are free to listen without answering, to receive without weighing, to watch without naming. Think of the paths we've taken, through rings of bent light and careful alignments, through grand discs balanced like coins, through the choreography of colliding galaxies where destruction and birth share a single rhythm. We stood at the edges of nurseries, where stars arrive wrapped in their first quiet heat, and at the doors of old red rooms, where giants set down what they can no longer hold. We learned how a breath can become a world, and how a world can become a breath again, and then we arrived here, where there is room enough for everything to rest in place. The body remembers how to belong to this pace. Shoulders lower, hands uncurl. The breath lengthens and thins, the way a stream does when it widens into a lake. With each inhale, the shore of wakefulness steps back. With each exhale, the water grows smoother. If you listen closely, there is a sound that isn't sound at all, the soft agreement between your heart and whatever it is that keeps clocks honest. It is slow, it is kind, it is enough. Outside, the stars continue their ordinary work. A few go on burning with the quiet politeness of lamps down a dark street. Others slip behind the roofline and do not mind being unseen. Somewhere, a telescope turns. Somewhere else, a dome closes for the night. But here, none of that requires you. The sky will keep itself. The numbers will not notice your absence. You are allowed to release even your wonder and let it idle like a boat rope in slack tide. The room draws close in a comforting way, not like walls, but like a shawl. The last threads of brightness soften to charcoal, then to the color of a held breath. In that softened light, small things take on their own gravity. The neat shadow of a plant on the sill, the patient outline of a book, the square of a window with the faintest echo of the outside pressed against it. Everything is present and already forgiven. You can be, too. Imagine, just for a moment, that the dark around you is not empty, but woven fine and strong, like the fabric of a sail. Imagine that all the distances we have crossed tonight have gathered into this one square of quiet, and that it will carry you where you are going without effort. You do not need to name the place. The dark knows the way. The body knows the tide. All that is asked is a simple consent to float. If thoughts still try to rise, let them arrive like low clouds and pass in their own time. They do not have to be argued with. They can be companionable and on their way. Let them thin as they travel, until only the clear air remains, the air that smells a little like night rain, a little like a door left open to a garden. You can step through, or you can rest on the threshold. Both are forms of peace. There is a kind of seeing that happens when the eyes are closed, the way a shoreline can be remembered by its sound, the way a familiar room can be found in the dark by the shape of the air. Let that be enough. Let the maps we drew earlier fold themselves with quiet creases and be set aside. What remains is simpler than knowledge and steadier than awe. It is only the steady drift of a small craft on a very wide lake, stars like seeds dissolving into the soil of the night. In the distance, beyond distance, the great net of space holds its form, filaments stretched, hollows resting, the long pause that gives the next note its shape. You do not need to travel there. It is already here, in the rhythm under your ribs, in the slow door of the lungs opening and closing. The same patience that measures the turn of galaxies is content to keep time for you. You can let it. Soon the last light in the room will dim to a thin silver and then to nothing at all. The window will become a softer square of night, and behind it, a fainter square, and behind that, only the suggestion of distance. The mind will step into that distance as one steps into water, at evening carefully at first, then with a small intake of breath, then with a smile no one needs to see. Even the smile can be put down. Even the carefulness can rest. If you wish, you can carry one small image with you, a slow spreading ring, not bright, not cold, just exact, or a cluster of stars like quiet beads, or the feeling of a hand being gently released. Let it ride along at the edge of your attention, where it can steer nothing and still be company. When it is ready, it will soften into the dark the way a footprint softens in wind, leaving only the promise that the earth remembers. And now the water is very calm. The oars are still. The shore is somewhere, but it does not ask to be found. All that remains is the long, unhurried glide. The breath is the boat. The night is the lake. The stars, seen or unseen, are the quiet, patient hands that keep you centered. Let them. When sleep comes, let it arrive like a tide under the hull, lifting without announcement. If it chooses to take you the long way, let the long way be welcome. If it comes at once, let it be as gentle as the closing of a book. Nothing is lost by setting it down. The story knows how to wait. The sky will keep time. The dark will be kind. And you will drift, light as ash, steady as orbit, into a silence that is not empty at all, but full of everything you no longer need to say.